Okay, this is a quick review for Algebra 1 on how to complete a bell curve. So, a bell curve is, you use a bell curve when you're looking at mean. So, this is your bell curve. It looks like a bell. Yeah, should look a little bit better than that. The middle of your bell curve would be your mean or your average, and then your data will move up and down, and each time it moves up or down, that is called a standard deviation. So these are the two pieces of information you need to create a bell curve or to answer questions about a bell curve. You need the mean and the standard deviation. So first, I'm going to give you some information. So I'm going to tell you that the average height for women, so the average height for U.S. women is 63 inches tall, which is about 5 feet 3 inches. And that the standard deviation is 3. So, a couple things. The mean, which on your calculator is an X with a bar over it, but when you're using a formula, it's kind of like this fancy U, would be 63. So that's our average or mean. And the standard deviation, which in your calculator is going to look like that, for our formulas, it's just going to be the kind of the fancy O, is 3. So to create our bell curve, we draw our bell. This is going to be 63. And now every time we move up and down our bell curve, we have to go by 3. So I'm going to add 3, and add 3. And then I would have to subtract 3, and subtract 3. So that gives you your bell curve. You don't have to create a bell curve to answer the following questions, but it's nice. Looking at the bell curve gives you an idea if your answers are correct. So let me turn the page so that we still need to be able to see that information. Okay, so here's our bell curve for the average height of U.S. women. I'll just move that up a little bit. So, Mrs. Hall, I am 67 inches tall. So, I want to know what my standard deviation, or what my z-score would be. So, let's go again. Let's go back to z-scores. The mean is 0, and then every standard deviation gives you a z-score. And the z-scores let you know if you are positive or negative, where standard deviations don't. If I say that I'm 2 standard deviations away, I could be 1, 2 this way, I could be 69, or I could be 1, 2 this way, and I could be 57. The z-score would tell me if it was 59 or 69 or 57. If I said I had a z-score of -2, you would know that it was 57. So I am 67 inches tall, so I want to know what my z-score is. So I know that I'm going to be falling right in here someplace, so I have to be, my z-score has to be between 1 and 2, probably closer to 1. So here's our formula. We do x, that's the element, that's what we're trying to find, or that's what we have, minus, that's the mean, divided by the standard deviation will give us our z-score. Z-score. So this is our standard deviation, and this is our mean. And then that's the number you're trying to, that you either have or you're trying to find. That's the element it's called. So I would be 67 inches tall, so I would go here, 67. My mean, 63. And my standard deviation, we went by 3s. So now I just need to do 67 minus 63. That's going to give me 4. Divided by 3 gives me 1.3 repeating. So I'm just going to say my z-score is about 1.3. So Mrs. Seaman, next door, is, I'm just guessing, she's shorter than I am. She is 62 inches tall. So we're going to find the z-score for 62. So we would do 62 minus 63 divided by 3. So 62 minus the mean divided by the standard deviation. And that would give us -1 divided by 3, which would give us -0.3 repeating, which means 62 would be just barely below the mean. So it should be really close, but it's going to be a negative number because we're below. So here's the next question you could be asked. Somebody has a z-score of 2.4. So that means this lady, whoever this lady is, her z-score is 2.4. So she's pretty tall, and it's going to be, her height should be between 69 and 72. Probably a little closer to 69 than 72. So we're going to use that same formula. We're trying to figure out how tall she is. We're trying to figure out the number minus the mean, which is 63, divided by the standard deviation, and this time we know our answer. So to solve this, we have to solve for x. We have minus 63 and divided by 2. You always do order of operations backwards when you're solving, so we need to get rid of this division. So I'm going to multiply both sides by 3. X minus 63 will give us 2.4 times 3, which is 7.2. And now to get rid of minus 63, I'm going to add 63 and get that the z-score is 70.2. So this person would be 70.2 inches tall. Okay, I can do the same thing. Let's do a negative standard deviation or negative z-score. So somebody has a z-score of negative 2.2. So I can go back to that formula. X minus the mean divided by the standard deviation equals the z-score. So there's my z-score. We know the graph was going by 3s and the mean was 63, and I'm trying to find that. So again, I'm going to multiply both sides by 3. And negative 2.2 times 3 will give me 6.6. And then again, because I'm solving, I'm going to add 63 to both sides. Hold on. That would give me a negative 6.6. Sorry about that. That's going to give us 56.4 inches, which should, again, make sense. Because it's a negative z-score, they have to be smaller than the mean. And negative 2.2 would be 1, 2. Put us a little bit behind 57, so they have to be a little bit shorter than 57. So again, you don't have to create the chart when you're answering questions about z-scores, but it does help kind of give you a visual to let you know if your answers are in the right ballpark.